So in this video here, we're going to talk about PaddlePaddle integration with Ultralytics. So we're going to go through the guide, how to set it up and everything, and also how we can export it. And then we're going to see a demo where we're going to export a YOLOv8 model. So a pre-trained one, but you can also use your own custom trained models. Going to export it to the PaddlePaddle format. We're going to talk about some of the benefits, some of the key features of doing this export and using this specific framework for running inference once you want to deploy your models. So we're going to jump straight into the Ultralytics documentation. If you go inside the guides tab up at the top, we will see all the different integrations we have. We have different optimization frameworks and all of that, which you can export the model into. So in the traditional computer vision pipeline, we have our data set, we train our model, and then once we want to deploy it into production, we export it into an optimized framework. So we have a bunch of videos covering like all of them over here to the left. So we're also going to do a guides walkthrough with the PaddlePaddle integration, but we have ONNX, which is a pretty standard format to export your model into. OpenVINO if you're using Intel hardware, TensorRT for NVIDIA hardware, CoreML for Mac and Apple hardware as well. So that's also some pretty cool integrations. But in this video here, we're going to take a look at PaddlePaddle. It's really easy to go in and work with Ultralytics and all the models, either pre-trained and also your own custom trained models, because we just need to call a single command and we can then export the model into the specific optimized frameworks. Also, if you're running benchmarks on our models, we will also be able to do and benchmark it with PaddlePaddle. So PaddlePaddle is developed by Baidu from China, and if you just scroll a bit further down, it stands for Parallel Distributed Deep Learning. So it's basically just an open source deep learning platform. Like you can both train models, you can deploy models and all that, and also optimize them for running in specific scenarios. So that could be if you want to run on mobile devices, smaller edge devices, and so on. If you go a bit further down, we can then see the key features of PaddlePaddle. So it has a dynamic to static graph, which basically just means that the models are translated into a static computational graph. And what that does, it is basically just optimizing the models. It makes it more efficient once we want to run inference with a model and don't want to train it any longer, because we just need the faster speed and still keeping up the accuracy when we want to run inference and deploy the models into production. So we see that this enables optimizations that reduce runtime overhead and also boost the inference performance, which is pretty much the key features and what we want to achieve with the optimization frameworks. And all of these integrations to the left are doing pretty much the exact same thing, trying to reduce overhead so we can run the models faster without really losing any accuracy. So they also have operator fusion here, so that also is inside TensorRT, but it's basically just like streamlining the computation and just reducing the overhead in the model weight and so on. So if you have a model where you have like different operators and so on that can be fused together, it's going to take care of that as well. So that will minimize the memory transfers and also just the computational steps by merging these operators as we talked about. In the framework, you can also do quantization. So that basically just means that you can have a model in floating point 32 and then you can quantize it down to float 16 bits, 8 bits, and so on. So that can also reduce both the model size and also increase the inference speed. So if you go from 32 bits to 16 bits for every single model weight, you're basically just halving your model size and you can then run faster inference and you don't really lose much accuracy. Of course, it depends on the model, your model size and so on, and also how much you'll be able to go down in performance. So you might get a slight decrease. So here we can see some of the deployment options in PaddlePaddle. So I talked about if you want to deploy it on an edge device, your server, GPU, and all of that, they have different versions and different options for that. So we have paddle serving here, which is basically just the deployment framework that they're using for these RESTful APIs. So we can serve the models in production environments. So you can do all the model versioning, you can do online A/B testing, and also the scalability. So you can basically just deploy your models in there and it will be exposed as an API. And then you can just host your models in there. It's easy to scale depending on the number of requests and so on. So that's a really cool feature. They also have this inference API here where you just like get an API, you can send a request to with your image, you get the response back, and then they're going to take care of all of it. This is pretty much just if you want to do a cloud deployment option. Then we also have PaddleLite and PaddleJS for JavaScript. The PaddleLite version is basically just if you want to deploy it on smaller devices, so embedded devices and mobile phones, it can optimize it even further and also run faster inference on like ARM CPUs, GPUs, and also different types of specialized hardware. So that could be hardware in mobile phones. Then we also have PaddleJS. So if you want to run it on web browsers, take the PaddlePaddle models, run them directly in your web browser, build on top of the models inside JavaScript, and build these web applications. it is also supported. So right now we can see here how to export it. So first of all, we need to pip install Ultralytics, and then we can just call this export command. So we have export, we choose the model. You can use a pre-trained one or a custom trained one on your own data set. And then the only thing that we need to do is specify this format, and that's pretty much it. If you want to deploy the models, again, you will end up with this model_paddle_model, and then you can directly just host them, serve them in here with paddle serving, paddle lite, and also paddle.js. You can find all the guides in here. So we're just going to take a look at it. It's going to open up the GitHub repository. They also have documentation in English. So you can basically just go through it here if you want to use some of these tools to go in and deploy and host and serve the model, so you keep track of the whole computer vision pipeline. So all of that is supported once you have exported the model into this specific paddle format. So let's now go and see how we can actually do it. I'm just going to copy paste this command. Let's just go with a nano model. And then after that, we can go in and run inference. So you can both do it in Python, but also from the command line. So right now, let's just do it inside Python. I've opened up the code editor. I've copy pasted the code in here. So we need to import YOLO from Ultralytics. We specify a model that could also be the path to your own custom trained one. Then we specify that we want to format it into PaddlePaddle. There we go. And then we can open up the model with PaddlePaddle, and we can run inference directly down here. In the source here, we can specify an image, PLL image, NumPy array, video streams, all of that directly webcam. So you can just throw it directly in here and you will get the results back here. Right now, I'm just going to run this Python script. It's going to basically just pull this image here. We're going to run it through a video in just a second, but let's just see how this script works out of the box. So we have paddlepaddle-inference.py. So I'm going to run this Python script. It's going to load in the model, export into PaddlePaddle, and we should be pretty much good to go. Again, remember to pip install Ultralytics, and it's just going to take care of all of it. There we go. Now we can see we have export image. We got the results back, and it should be saved inside our runs directory. We can also just specify that we want to show it here. So we set show equal to true. Let's just rerun it, and you can specify all these arguments. You can find them inside the documentation for this predict function. So just shortly here, we can also go in and call save equal to true. And while we're doing that, I'm just going to find a video so we can run inference on that and see how it works in real time and also on a video stream. So just have a couple of videos over here to the left. Let's just start with the Dubai Mall. So I'm going to copy the relative path, and we can just directly swap it out in here. And you can also specify a video stream, USB camera, your web camera directly, and it's going to run inference on that. So now we're both going to show it and also save it. This is the nano model that we are running, and we can extract all the results. We see all the frames. We can see the millisecond that it takes to run the image through a model. Right now it's running on my MacBook CPU around 150 milliseconds. So it really depends on the hardware that you're running it on, the optimizations that you're doing. You can do quantization as we talked about, but this is pretty cool. We get some really nice results. Even though we're only using the nano model, we're still able to detect these persons in the background. So this is a pretty cool example. Let's go in and find another video. So you also have this PPE or the queue management. So let's go and take this checkpoint video as well. I'm just going to run it here so you guys can see it. It's basically just a line queue here. Could be a metro station, airport, and so on. So let's go in and swap out the path. This is everything that you have to do. And the results generated here, you can extract all the individual bounding boxes, classes, and so on directly. We have tons of videos covering that, so definitely check those out. So right now, it's going to run it again. There we go. We can see we're pretty much detecting all persons in the frame. And inside our directory over here to the left, this is basically just the path where we're exporting the model into. So now we have our YOLOv8 nano model, and we have this paddle model. We see everything in here. We have the inference model, we have the metadata, so we can open that up. We'll basically just all the classes, the image size, and so on. So it is very similar to the data YAML file. We have the X2 paddle code and so on, basically just for setting up the model because we need that. And we also have the ML package with our data. We have our weights and we have our ML model. Then we can basically just take those files, serve them with PaddlePaddle, export it into the different embedded frameworks as well, or you can use it with JavaScript. So this is pretty awesome. Another framework where we can go in and do optimizations once we want to take our computer vision models and deploy them into production. So it really depends on your use case and project. If you want to run TensorRT, OpenVINO, PaddlePaddle, ONX and so on. But if we want to deploy models into production, we should not use the PyTorch version, but something specifically for the hardware that we're running and also our specific use case. So I hope this video here has helped a ton. Definitely going to check it out. And then I'll just see you guys in one of the upcoming videos. Until then, happy learning.